Alright, let's talk about the basics of fractions. We're going to look at simple definitions, what words mean. We're going to look at breaking apart fractions. We're going to have some visual examples. We're going to have a lengthy word problem that has fractions with fractions in them. We're going to have ways to estimate quickly and a way to kind of get an exact percentage or decimal number when dealing with fractions, all in this one video. It sounds like a lot, but it's pretty easy once you actually see it. Alright, so the first thing we're going to do is cover the thing everyone knows, and that's the words numerator and denominator. And of course I didn't accidentally write them on top, and those are, I split them with a line because the numerator is the number on top and the denominator is the number on the bottom. But what I want you to start doing, especially on this test for speed, is think of them as the part and the whole. If that doesn't make sense right now, hopefully this pizza analogy will. Hopefully you're not hungry and you actually pay attention to the video instead of thinking about lunch or dinner. So, a pizza has a whole pizza. And that is an apprentice's pizza. We're not proud of it, but we're still going to sell it. It has 8 slices. 4 and 4, that is 8. So one whole pizza has 8 slices. And when it's delivered and fresh and nobody's had a chance to start eating it yet, there are actually 8 slices filled in, ready to go. And your party starts, your kids come home, you get hungry, and let's say 3 of those slices have been eaten. Well, we went from a whole pizza, which 8 over 8 is equal to 1, reduced, or 1 over 1, which is equal to 1. So you had 1 pizza, but now someone ate 3 slices. So goodbye. 8 minus 3 leaves you with 5 slices left, or 5 parts. In this case, they happen to be slices out of the 8 that are required for a whole pizza. So you are now at 5/8 of a whole pizza, or 5 parts or slices left out of your whole pizza that came originally with 8 slices. So let's say your party's getting a little bit more popular and your best friend shows up and they say, well, I invited a few extra people and I went ahead and brought 3 more pizzas. Ooh, they went to a worse shop than you did originally. And they're not perfect pizzas, but it's a party, so who cares? Alright, well, now I want you to think about it. Would your denominator change? Your whole, we're worried about the number of whole pizzas you have. How many slices do you need for a whole pizza? I'm going to give you a second and think about, would that change proportionally to the number of pizzas you have, or does the number of whole slices in the number of slices in a whole pizza change because you have more pizzas? No. So still you have 8 slices to make a whole pizza. It's just now you have more parts. You have enough parts to make 4 whole pizzas. So to figure out how many parts we have, instead of counting each one, do 8 times 4, and we're going to know that's 32. So now we have 32 parts, or that's slices, and I should not have put that bar there because I don't want to confuse the matter. We have 32 slices, and we still need 8 slices to make a whole pizza. So if we did our math right, we should be able to come back and say, well, 32 divided by 8 is equal to 4, which happens to be the number of pizzas we have. So your party's getting going. Everyone's tired of dancing or staring at each other awkwardly, hoping that dancing will end, and they start eating. Well, your pizza's a hit. The whole thing's gone. Your friend's pizza's pretty good, so they eat a little bit more than half of it. Well, again, the number required to make a whole pizza doesn't change. But let's figure out what fraction of the number of pizzas you have left actually is. So we know we have 8 here and 8 here. we'll say this piece is gone to the wind, so 1, 2, 3. So if I do 8 plus 3, we're at 19. Okay, that's simple. Now let's just look at it real quick and convert it back to a whole number and see if it makes sense. Well, 8 goes into 19 2 times. That is a whole number, which coincidentally happens to be what we call our denominator, the whole, and we have 2 whole pizzas left. Now we're looking at what's left. Well, 8 times 2 is 16, so I'm going to take the 16 that the whole represents, because 2 times 8 is 16. And I can subtract that from my parts, because I already said I have 2 whole pizzas. And that leaves me with 3 parts left. Well, look at that. 1, 2, 3. And the number of slices to make a whole pizza still hasn't changed. So we're at 2 3/8 pizzas. Parts to the whole. I think that is really the easiest way to look at it. So now we're going to look at money, because if pizza doesn't get your attention, money should. Alright. So we have, excuse me. Let's go green, because we're talking about money. Alright, so we have a dollar bill. This may not look like your dollar bills, but I'm proud of it. Yeah, full body shot of Washington on this one. That's a powdered wig. He's happy to be there. His eyes aren't. Alright, so we know that there are $1 is equal to 100 pennies, which just happens to be called cents. 100 cents. Well, a percent is out of 100. So I think that's where we got the slang for pennies, at cents. I think it's not a coincidence. I think it's just naturally evolved with the language here. So now we know we have out of 100, and we have 100 pennies, which we call cents, and percent is out of 100. So we can count by pennies, but we're cool with our change. We actually just save our quarters. So let's make these a cool blue. And we know that we have each quarter is worth 0.25, which again I don't think is a coincidence, but it's the evolution of, you know, being quick with our talking. A quarter is represented as over 4. So 1 quarter is 1 over 4. 2 quarters, 3 quarters, 4 quarters happens to make a whole. And we call these quarters because they are each a quarter of the dollar. Oop, oop, oop. So that's worth a quarter, that's worth a quarter, that's worth a quarter, and that's worth a quarter. So let's see here. So we can say that 25 cents is worth a quarter. So having this, we actually end up with our 100 pennies in a more condensed form. That's what we're going to work with, because I don't want to draw 100 pennies. Alright, so we're going to say we have 2 quarters, which is 50 cents out of 100, or this is 50 parts, and in this case it's cents, out of a whole, which I flipped my brackets on these. I hope that doesn't confuse you. Whole dollar. So what does that mean? Not much yet, but I want to show you something. Hopefully this will make a little bit of sense. So I have 50 parts, or 50 cents out of the dollar. I'm going to go ahead and divide out here. I'm going to have 5 over 10. These are reducible by 5. I can both divide. That's 1/2. 50 cents is 1/2 of a dollar. So we're going to do it again real quick. But this I'm going to have it as 1 quarter. And again, it's going to show you why I think we call them a quarter today. So I have 1 quarter, or 25 cents out of 100, or 25% of a dollar. And I'm going to look at this and go, well, 25 goes into 25 and 100, so I'm going to divide by 25. And I'm left with 1 quarter. Well, again, I don't think it's a coincidence that these values are equivalent. So if we can kind of start thinking in this sense, it's easy. If I said I have 75 cents, well, I have 75% of a dollar, or 75 over 100. And as you kind of get more comfortable doing this with money, heck, if I have, I don't know, let's say I have 2 pennies, I'd ask you for feedback here because I hate randomly generating stuff. I have 3 nickels and a dime. I'm going to figure out what their value is, and then we're going to figure out really quick what percentage of a dollar we have. Well, that's 0.02, right? 2 pennies. 3 nickels is 15, and a dime is 10. So it looks to me like we have 27 cents. Well, so what? 27 cents would be 27 over 100, which, if you don't understand why I did that, let's take a little aside here and say 27 divided by 100. Well, we have to add the 0 here, which will give us the decimal, and we can go and get rid of this. And then we have 2, which is 20, 77, 27 cents. We're right back around to where we started, so we did that right. So now we have 27 cents out of 100, 27% of a dollar. I really find it easy to think in the terms of money. So I hope you have found this helpful. Now we're going to move on to something a little bit different, but again, not scary at all. So we're going to continue our train of thought here on the 50 over 100 and stuff, and know that percent is out of 100. So anything I give you over 100, you should instantly, without even really having to think about it, be able to throw back the percentage to me. So I'm going to write down some numbers, and I'm going to write them down, and as soon as I'm done writing them, I'm going to write their percentage next to them. I hope you beat me to it by the time we finish the third one, because it's really easy anytime you see it over 100. And I'm going to go ahead, so you don't have to worry to make sure I'm trying to trick you or anything, that we're going to go and put 3 out over 100. Number 1, that's 45%. And if you think about it, money, 45 pennies out of 100, 45 cents, 45%. 63%. 71%. 71 cents towards my dollar. I have 71%. That's really easy when it's over 100. Let's say now we're going to do a little bit different. I'm going to say we have out of 25. So I have 3 out of 25. All we have to do is recognize our denominator and say, well, how close can we get? And we're going for a percent here. What do I have to multiply 25 by to get to 100? Well, 4. So if I have to multiply this by 4, I multiply this by 4, and I am at 12%. And if you do this enough, it'll become natural where you're not even thinking, oh, what do I have to do to get here and here? You will look at 3 over 25 and just say, multiply 3 by 4, and I'm at 12. Let's do another one, and let's see if you get it before. I'm going to go ahead and give you, like I said, 25 first. That's 24%. I'm not even going to go over 100 anymore. I don't think we need it. It is really that easy, and I hope you're smiling right now because this is helping you in some way. Let's do a little bit harder one. Is that what you got? I hope so. Yeah, 15 times 4 is 60%. If you, I think of hands of the clock and just say how many times 3, 6, 9, 12, 3, 6, 9, 12, and I know where I'm at. If that doesn't work for you, you can also just say, what's 15 times 4? Well, if you're not going to do it really quick in your head, 4 is the same as multiplying a number times 2 times 2. So 15 times 2 is 30, times 2 is 60. You're done. That's all you have to do for these. Alright, now we're going to throw a loop in here. I'm going to say, well, now we have 20 over 33. The dreaded 3. You know, every time I tutor, we always talk about when you're dividing by 3, what are you going to have? You're probably going to have a repeating number. What do we do here? Well, this isn't going to give you the exact amount. Punch it in your calculator if it's on the test and you have a lot of these. But if you're doing the competency 1.1 ordering on the number line, you know, and they give you 5, 2, -3, and pi, and then they throw 20 over 33 at you, and you're thinking, oh geez, what is that going to be? Well, these are really easy. You can just knock these right on out. You know that's 3.14. But what are you going to do with this 20 over 33? It shouldn't stress you out. So our goal in the previous ones that were a lot easier, when we were over 25 or over 100, well, when we're over 100, but when we're over 25, our goal is to get to our denominator to 100. What can we do here? What's the closest we can get to 100 with 33? Yeah, I think so. Geez, I guess I answered that to myself. I'm going to multiply both of these by 3, and we're going to end up with 60 over 99. Well, there's two ways to look at it. We can say this is close enough to 100, so we can say it's approximately 60%, and that's kind of what I would do. Or we can go ahead and punch it in the calculator and check and see if maybe I am a little bit off and crazy. So we're going to put 60 divided by 99, and we're going to end up with 0.606060 repeating. Well, 60% and 0.60, let's put it in percentage, 60.6%. Now let's look at the numbers that I crossed out. Is 60.0 or 0.60, which is what it is in the decimal form and what we would want to use on this question. So this is not this. This is actually 0.60606 repeating. Did that mess you up at all if I were to just go ahead and say it's 0.6? No, on this problem it's not. They're probably not going to be so close on the test that you're going to be thrown off or get it incorrect because you use this quick estimation instead of bringing out the calculator and spending the extra 15 or 20 seconds. And I know I press time, but sometimes 15 to 20 seconds is enough to help you catch that one little mistake. And so many people come to me with scores of 190, 188, 194. This could be the difference between your pass and fail. You know, not having to sit here and listen to these videos anymore. 15 seconds saved is still great no matter what. Alright, I hope that helped. Let's see, do we need to do that? No. Alright, so now we're going to move on to the word problem I promised. And it is a long one, and it is a little bit confusing. And I'm going to give you a few minutes to pause the video, please. Let's just look at it. Alright, you want to start a company that builds and sells birdhouses. For each birdhouse, you need 15 screws, one 1 by 4 inch by 8 foot long board, 1 peg, and half a tube of caulking. Friends and family have helped you get your business started and have donated 90 screws, 8 boards, 9 pegs, and a 12 pack of caulk. How many birdhouses can you build? Let's stop there. Let's just look at this. How many birdhouses can you build? We know the parts we were given. We know the whole amount we need per birdhouse. So what is really important that we look at here? Well, let's go ahead and start writing it down. I don't need word help. I should switch to this. Alright, let's switch to the other monitor. So what do I need to know first? Well, I need to know my parts that I have and how many of those parts it takes to build a whole birdhouse. So I'm going to know that I know you don't have the list in front of you right now, but we need screws. And we're not going to worry about any of the numbers right now. We're going to make our materials list. Screws, the board, a peg, and caulking. Now this is going to be the hardest one. These two look pretty easy. And this one's going to take a little bit of quick math. Alright, so now we're going to switch over just so you can kind of see, and I'm going to write it down while you're looking at the question, if my mouse was here. Alright, so our awesome friends and family gave us 90 screws, 8 boards, 9 pegs, and a 12 pack of caulking. Okay, let's switch back and let's do this. What is going to be, we have 90 parts for the screws. We have 90 screws. That's the number of parts we have for a birdhouse. How many screws do we need per birdhouse? 15, so that's going to be our denominator. How many boards do we need for a birdhouse? 8 or 1? Well, the directions say we only need 1, so that's going to be our denominator. How many pegs? Oh, conveniently 1 again. I wonder who wrote this question. Somebody who probably wants to make a quick video. And a 12 pack of caulking. Well, now he just messed himself up. If you only need half a tube and you have a 12 pack 12 hole, now we have another fraction within a fraction. So a 12 pack, and we're going to switch over to talk about this really quick. So we have a 12 pack of caulking. Let's just say we're really concentrating on this right now. A 12 pack of caulking is the same as 12 hole, right? And we're going to divide it because we only need half of that. Everybody hates seeing fractions on fractions, but all we have to do is take the denominator, the fraction in the denominator, and multiply the fraction in the numerator by this fraction's reciprocal. So really all we need is 12 over 1 times, and the reciprocal of 1/2 is 2. And we go straight across and we have 24 over 1. Awesome. So this tells us we have enough to make 24 whole birdhouses. So now we can come back here, and we're not even going to write 12 packs. We're going to write that we have enough to do 24 whole birdhouses. That looks so much better. Now, what was going to be our little bit of math, and it was pretty easy. Now we have three of our supplies out of 4, 75% of our supplies. I hope you could think of it that way, because I did 3 over 4 times 25, 3 times 25, 75, are now over 1. So now we know right away, without any more math, we have enough to do 8 birdhouses, because we have enough supplies to from the boards to make 8. We have enough to make 9 from the pegs and 24 from the caulking. All we have left to do is think about how many parts do we have to make whole birdhouses. Well, I happen to know that 15 goes into 96 times. 2 ways to do it. You can look on a clock and just say 3, 6, 9, 12, 3, 6, 9 until you have your 6 whole. Keep subtracting 15 that way. I don't like it that way. The way I like to think about it is, I have 15, 30, which is 15 times 2 is 30. 30 times 3 is 90. So that's 3 times 2 is 6. So now I'm going to look at this and say, well, how many whole birdhouses can I make? Well, we're going to compare our numbers and say, well, 6 is the smallest number. So I do have enough to make 6 birdhouses. So that's a pretty good start. Ooh, that's a bad one. I think their generosity is definitely going to get you off the ground here. Well, now if I make 6 whole birdhouses, I need to figure out, what am I going to do? How many boards am I going to end up using? 6. So I'm going to subtract 6 and have 2. Here I'm going to subtract 6 and have 3. And here I'm going to use, because we converted the caulking, another 6. I'm going to have enough to make 18 more. So the second part of the question, and that's probably the part that kind of stresses people out right away, is, of the remaining supplies, how many more birdhouses do you have enough material to make? Well, now we're going to come back. Oh, I added a 2. That is not the answer. That is my eraser on the other screen. I'm going to come back here and just say, well, now we know how many parts we have left over. So what do? We're going to write 2, 3, and 18. So when you go to the store, you know you have enough boards to build 2 more. You know you have enough pegs to build 3 more, but you have enough caulking to build 18 more. If your birdhouses are a hit and you can afford, you can buy 16 more boards and 15 more pegs, and then when you get home, you'll have enough to make 18 birdhouses, except for you've used every screw you have. So how would we figure out, looking at this, how many screws do we have to buy to build 18 birdhouses? Well, we know we need 18 whole birdhouses, so we would multiply it by the denominator, and that would be, your battery is low, 18 times 15, we need 270 screws. Luckily those in the pegs are probably the cheapest part of these projects. So, yep, there you go, 270 screws, 16 more boards, 15 pegs, and you'll run out of caulking just as you finish your birdhouses. I hope this was a huge help. If there's any questions you still have, throw them in the comments. Email me. You can find my email on my page, my YouTube page. If you have any questions, I would love to answer them. If you see any mistakes, I would love to hear from you even more than the questions. Not that I don't want the questions.